Hi, welcome to my Metal Hub YouTube channel. Today I am going to talk about brittle fracture. I have a interesting question today related to Griffith theory. Actually, it is about to calculate the fracture strength of steel. And before that, I want to talk a little bit about brittle fracture. Actually, it is very common in amorphous materials, but in crystalline materials also like steel, we can see brittle fracture. This brittle fracture can be occur through grain boundaries actually. Uh, what happened when in low temperatures and higher rate of strain, brittle fracture can be happen even in steel. I think everyone here we know about the Titanic, no? What happened to that ship? Like that. The specialty in brittle fracture is compared to ductile failure. Okay, in brittle fracture there is a significant or no significant minor deformation happen and crack propagate as nothing. Okay, uh, this Griffith theory actually we can use for perfect brittle materials like glass, but for metals also we can use, but better to do some adjustment for plastic deformation there. Okay, so in this equation you can see that fracture strength is inversely proportional to the C. Actually here C is micro crack length. Okay, actually brittle fracture in crystalline materials happen due to micro cracks. Okay, but every micro crack is not result to failure. That micro crack should be higher than certain levels, then only due to external strength or fracture strength it will be propagate. Okay, now in this equation we are going to find out the brittle fracture of steel. They have given the elastic modulus of the given specimen and surface energy is given. Why surface energy? Actually surface energy here gamma is noted. Surface energy because in brittle fracture in grain they have some energy. Okay, we call strain energy. When what happen here is this inheritant this strain energy is losing, it will release when crack propagate. You know, to make some surface, okay, energy is required. This energy given by this strain energy. So this surface energy is very important, do a very important role in brittle fracture. Anyway, for given material, surface energy and Young modulus are same. So what determines the brittle fracture strength is that micro crack length. You can see since it is inversely proportional, when micro crack length is very high, okay, we need only small fracture strength to propagate this crack. Okay, obvious. Then by using this formula, let's going to solve this problem. Okay, now sigma equals square root of 2e gamma divided by 5c. So E is 200 giganewton per square meter, so and gamma is 1.5 joules per square meter. Then phi is we know, and C, the micro crack length here given by 8 micrometer, but here C is half of that crack. That we should note it very well. Okay, whatever the crack length we have to divide it and we have to use for C. Okay, we cannot use same C there, same micro crack length in C. Okay, that's very important, otherwise you will not get full mark in your question. Okay, so finally brittle fracture strength for this phenomena we are getting as sigma equals 218 meganewtons per square meter, but actually in actual case the strength required for brittle fracture is higher than this value. So generally speaking, this crack will not propagate and this micro crack will not result to failure in this material. Okay, have a nice day. We will meet again with this type of simple math. Until that, stay tuned.